Can you hear me okay now?
Yes, I can hear you fine.
Great, great. So I'll start if that's okay. So, morning everybody, and welcome to the third and final day of the environmental and aerosol transmission of COVID-19 program. So I'm Chris Payne. I'm from Imperial College, and I have had the privilege of co-leading the RAMP Task 7 on this subject with Professor Paul Linden from Cambridge. So can I just mention the posters from yesterday? I think there were some technical issues yesterday, and I'm not sure if people could attend the posters as well as they perhaps visit the posters as easily as perhaps they should. And so could I encourage people who are interested in the posters to visit the website and check out the posters there. So I also believe the discussion, the output of the discussion sessions will be represented in some way on the web as well. So we had an enjoyable and very informative set of presentations yesterday, and I'm just going to summarize, try to summarize some of the things that were said. So, so here, I think you can see a list of the presentations from yesterday, starting with Paul Linden, and he made the point that the basic three routes of transmission are the formite route, the droplet route, and the aerosol route. And I think also the considerable uncertainties associated with the virus, the airborne transmission, were also highlighted. So these are numerous, including some of the turbulent flow uncertainties associated with the airborne transmission. But I think two big uncertainties associated with the virus itself are the viral load in terms of what needs to be, what's needed to get infected. And this also includes the exposure time, which is very important in different settings, for example, on long journeys on planes or in working environments. And the second large uncertainty is associated with the virus is what the load is on the breath. So I'm just going to go through, just pick out some of the things that from the presentation. So Kath Noakes gave a very good presentation on understanding transmission mechanisms and uncertainties. And so some of the things that were brought out are the variations of transmission when people have different sort of activities. For example, when people are singing or speaking, or have an elevated sound level, and also the variability in the particle concentrations can vary by 1 or 2 orders of magnitude in these different situations. Also, even within a few hours, the viral load from a person that's infected can change massively within just a few hours. So that also contributes greatly to the uncertainty of the virus. And we need to link exposure to risk of infection, and that's obviously that's one of the key important aspects. And the importance of close range transmission. So most of the transmission is through relatively close ranges, so less equal to 1 meter, and the chance of longer exposures increase the probability of becoming infected, of course. Surface contamination may be important, and uncertainties were highlighted. And I would just add to that I think although the different uncertainties were highlighted here, I think it's really important that we apply uncertainty quantification methods and minimization methods within this. And Lydia Morawski gave a very informative talk on the airborne transmission of respiratory infections. And she highlighted the confusion right at the start of the pandemic, in which WHO said that COVID is not airborne. And also there was confusion over masks. People were saying there was no evidence of the ability of masks to protect people from infection. And now, of course, that's become mandatory. And Henry Burridge gave a very informative talk on who is the lead of the ventilation group within Round 7 on ventilation in indoor spaces. And he highlighted the use of CO2 for monitoring and as a surrogate for potentially virus-laden air, and the need for adequate ventilation, and also the use of energy and to heat indoor spaces, and the use of the Wells-Riley approach to determine dose and dose response approaches to determine infections, help determine infections. And okay. So Mark Settler, he's also a lead of the of one of the RAMP groups on the aerosol on physics, and he discussed the 3-mode size distributions, for example, of droplets from the lungs, and they're 3 modes because they come from different parts of the lungs. And Oliski Kowantko from Surrey discussed the transmission from hard surfaces and highlighted the survivability from surfaces as well as the of the virus from various surfaces, as well as in the air. And Lydia Morawski from MIT talked about respiratory emissions, and again highlighted the droplet size distributions, and talked about some of the physics associated with the multimodal distributions of droplet sizes. So onto the breakout sessions. So that's a very brief summary of some of the outputs. I'm just going to give a one-line summary of the breakout sessions, and I wonder if we could put the questions that were asked, that the breakout sessions were asked to discuss. So The breakout session chaired by Marco discussed the importance of sensors in different environments and contrast in different environments, including the variability of consult halls, and also discussed the variability, the survivability of the virus and transferring the virus via the mouth, nose, or eyes, for example. And the breakout session by Olewski discussed the evidence of the formite transmission being lacking, the survival on surfaces of the virus over hours, as well as in the air over hours, discussed tracing infections, and talked about CFD modeling of specific situations not being general enough. And they also discussed CO2 as a proxy for aerosols, which is a common theme. So the last session, chaired by Lydia, discussed the pros and cons of full CFD versus averaging methods, given the short timescales we are working to get results from. So that's a very brief introduction. Sorry, a very brief summary of yesterday. So just contrasting yesterday with today, session 4, the next session, will discuss applications like hospitals and safe occupancy times. And session 5 after that will discuss infection dynamics and transmission. And the breakout rooms will then discuss future directions, and we'll finally wrap up. So that's my brief summary of yesterday.